Hi everybody, welcome to the third video for arcs and sectors, and this one is titled Finding an Angle from an Arc or a Sector. So in this case we're given either the length of the arc or the area of a sector. Here are the two examples I have, and as you can see we don't know what the angle is. That's what we're trying to figure out in both of these problems. Now if you think about an arc, previously we mentioned that an arc was just a fraction of the circumference, and that's what we're going to use. We're going to use the fact that we know that this 19.82 is only this fraction represented by x out of 360 degrees of the full circumference. So the first thing we should know is we should know that we should find the circumference of this circle, and the formula we use is circumference is pi times the diameter. So as always, we usually take pi to be 3.14. It just saves us rounding in the end. And we have 3.14 times by our diameter. And here in our example, you see we have a radius of 8, but we don't want the radius, we want the diameter. And the diameter goes all the way through. So in this case, it's going to be 2 lots of 8. So we're multiplying by 16. Quick maths on the calculator, 3.14 times 16, and our answer should be 50.24 centimeters. Now that is the circumference of the full circle. We have an arc that we know is 19.82 centimeters in length, and we're going to use that to find our angle x. Now to find our angle x, we have to represent this arc as a fraction of the full circumference. So it's going to be 19.82 over 50.24, because this is our arc and this is our circumference, and we're timesing that by 360 degrees. So we're taking this fraction of the full 360 degrees. Once again, some calculator maths. So 19.82 for our arc, 50.24 for our circumference, and we're multiplying that by 360, and we get rounded. Our angle should be 142 degrees. So I've rounded this to the nearest whole degree to get this. Now similarly, with when we have a sector, here the sector is 24.48 centimeters squared. Our radius is 6.2, and our angle, we don't know that. That's what we're trying to find. So instead of using the circumference, we're using the full area of this circle. And the way we calculate the area is pi times the radius squared. And we have a radius. This isn't a diameter, it's a radius. So our area is 3.14 times 6.2. Now on our calculator, 3.14 times 6.2 squared. Should probably put the squared in there. Gives us 120.7016. Now since we have that area, we have the area of the full thing including our sector here, we're going to use this sector as a fraction of the entire circle, similar with what we did with the arc and the circumference, to calculate our angle x. So we have this fraction is 24.48 out of the full 120.7016, and we're taking that fraction of 360. So once again, back to the calculator, 24.48 divided by 120.7016 multiplied by the 360 degrees, and we get 73.013, but I'm just going to round it to the nearest whole degree to be 73 degrees. Now, the key things you need to remember here is you need to remember your formula for circumference, your formula for area, and knowing when to pick which one. So an arc goes with the circumference because it is part of the circumference. The sector goes with area because a sector is just part of an area. It's just a fraction of the area. And you use that to create this fraction out of the 360 degrees. Here's a fraction for our sector, our 300 degrees, and some rounding.